Hello everybody. Today we are going to discuss geometry concepts in this video. Geometry questions appear in CAT, GMAT, SSC, IBPS, E-Litmus and many other competitive exams. In this video, we will refresh various theorems and formulas which we learnt in class 9th or 10th and which are used in solving geometry questions in competitive exams. In this particular video, we will learn lines and triangle, while in other two videos, we will learn circles and quadrilaterals. There will be separate videos in which we will apply these theorems and concepts to solve the questions which are asked in various competitive exams. If you face any doubt, any query in any of the concepts explained in this video, please mention it in comment section. I will try to resolve the same either in the comment section itself or through another video. Now let's start with the first topic in geometry, lines and triangles. So if we look at the first concept, L and M are parallel to each other and these are intersected by a transversal P. So let us see what are the various angles which are formed. First of all, let's talk about vertically opposite angles. Now for vertically opposite angles, only two lines are required. So if two lines are intersecting at a point, then vertically opposite angles are formed. Here A and D are vertically opposite angles. Similarly, B and C are also vertically opposite angles. So vertically opposite angles are when these are on the either side of the lines. So A is on one side of the line, D is on another side of the line. These are vertically opposite angles. Similarly, F and G would be vertically opposite angles and E and H also vertically opposite angles because line P and line M are intersecting here. Now let's look at next set of angles, which is corresponding angles. So for corresponding angles, two lines are parallel to each other and these are intersected by a third line. Then corresponding angles are formed. Here A and E are corresponding angles. So these angles are on the same side of the transversal and they are also on the same side of the parallel lines. So A is above line L and E is above line M. These are called corresponding angles. So corresponding angles are also equal to each other. So A and E are corresponding angles, C and G are corresponding angles, B and F are corresponding angles. Similarly, D and H are corresponding angles and corresponding angles are equal to each other. Next set of angles are called alternate angles. Now alternate angles are again formed when two parallel lines are intersected by third line. So here C and F are alternate angles. So these are lying on the opposite side of the transversal. So line C, angle C is lying on the left side while angle F is lying on the right side. And they are inside these two parallel lines. So these C and F are called alternate angles and they are equal to each other. Similarly, D and E are also alternate angles. They are also equal to each other. Now, this is a very simple concept which all of us know that on a straight line, the sum of all the angles is 180 degree. So here angles on one side of the line. So angles sum of angle 1, 2 and 3 is 180 degree. And angles around a point, so if there are multiple lines which are intersecting at a point, then angles around this point, the sum of angles is 360 degree. Now let's talk about triangles. So triangle is an enclosed figure by three sides, right? So here AB, BC and CA are the three sides and they are forming three angles named small a, small b and small c. So this is a triangle. Now the sum of interior angles of a triangle is 180 degrees. So the sum of A, B and C is 180 degree. Now another concept is that the sum of three ordered exterior angles is 360 degrees. So first of all, let us understand what is an exterior angle. So exterior angle is nothing but when one of the sides of the triangle is extended to the to outside the triangle, then exterior angle is formed. So here BA is extended beyond the triangle and angle 1 is formed. So this is called exterior angle. Similarly, here angle 3 is formed and here angle 2 is formed. Now the thing is that When will the sum of 1, 3 and 2 be 60 degree? When these are ordered. So the keyword is ordered. What is the meaning of ordered? That when we extended BA in this direction, so we are representing it by this arrow. AC is extended in this direction, represented by this arrow, and CB is extended in this direction, represented by this arrow. So when all the three sides are extended in the same direction, so here it is clockwise direction. So all of them are extended in clockwise direction, then the sum is 360 degrees. Similarly, if they are extended in anti-clockwise direction also, then also the sum would be 360 degrees. So here CA is extended in this direction, so represented by this arrow. AB is extended in this direction and BC is extended in this direction. So they are extended in anti-clockwise direction. So again, the sum would be 360 degrees, right? So if one line is extended in clockwise direction while another is anti-clockwise, then the sum won't be 360 degrees. So for the sum to be 360 degree, these have to be ordered exterior angles. Another important result is that the measure of an exterior angle is equal to the sum of the measures of interior opposite angles, which means this angle 3, this is equal to the sum of A and B, because these are interior opposite angles. So these are interior angles and they are opposite to angle 3. So angle C is adjacent and angle B, A and B are opposite angles. So angle 3 is equal to A plus B. Similarly, for angle 1, interior opposite angles are B and C. So 1 is equal to B plus C and 2 is equal to A plus C. Now let's look at the type of various triangles. What are the various kinds of triangles? So we can categorize triangles based on the length of their sides. And based on that, there are three kinds of triangles. Equilateral triangle, when all the three sides are equal. Isosceles triangles, when two of the sides are equal. And scalene triangle, when none of the sides is equal to each other. In equilateral triangle, all three sides are equal to each other and all three angles are also equal to each other, and these three angles are equal to 60 degrees. In an isosceles triangle, any two lines can be equal to each other. Here we have shown AB and AC are equal. It can be AB and BC are equal to each other, or maybe AC and BC are equal to each other. In all these cases, it would be an isosceles triangle. But here, in this particular case, AB and AC are equal to each other. So we are calling it an isosceles triangle. So when AB and AC are equal to each other, their opposite angles will also be equal to each other. So angle opposite to AB is angle C. Angle opposite to AC is angle B. So B and C will also be equal. So B is equal to C. In a scalene triangle, none of the sides is equal to each other and none of the angle is also equal to each other. Now there is another categorization of triangle based on the angles in those triangles. So first kind is right angle triangle. So this is a right angle triangle where angle C is 90 degree. So here we have represented small a, small b and small c as the length of the sides, right? So what is the relationship in the length of the side in these triangles? So in a right angle triangle, c square, which is a hypotenuse square, is equal to a square plus b square. This is the Pythagoras theorem, nothing but Pythagoras theorem. Then there is an acute angle triangle. Acute angle triangle means all three angles are acute, or all three angles are less than 90 degree. So this is called an acute angle triangle, and in acute angle triangle, c square is less than a square plus b square. Now here, c can be any of these sides, right? So whether this side or this side or this side, any of the side, square of any side is less than the summation of the square of other two sides. So here it will be a square also less than b square plus c square, and b square also less than a square plus c square, because this is an acute angle triangle. In an obtuse angle triangle, at least one or only one angle would be greater than 90 and two angles would be acute angle. In fact, in all the triangles, in any triangle, at least two angles would be acute angles. Maximum one angle can be obtuse or 90 degree. So here one angle is greater than 90 degree or one angle is obtuse angle. So this is called obtuse angle triangle. In obtuse angle triangle, this side C, this is the biggest side because this is opposite to the obtuse angle. So C square is greater than A square plus B square. So here the square of the greatest side, square of the biggest side would be greater than the summation of the square of other two sides. So c square is greater than a square plus b square. Now other results in the triangles are like this. Sum of the length of any two sides of a triangle is greater than the length of the third side. So if we add a and b, so a plus b would always be greater than c. Similarly, b plus c is always greater than a. Or you can say a plus c is always greater than b, because sum of any two sides would always be greater than the sum of the third side. The third side. Similarly, difference of any two sides is always less than the third side. So here, if we take out the difference between b and c, then that difference would be less than a. Similarly, if we calculate the difference between a and c, then that difference would be less than b. And if we calculate the difference between a and b, that difference would be less than c. And this is true for any kind of triangle. So all these theorems, all these results are true for any kind of triangle. Now another rule is that greater angle has a greater side opposite to it. So here in this triangle, this is the greatest angle. So this side would be the greatest. In this particular triangle, this is the greatest angle, 90 degree. So this side would be the greatest. So if you know the greatest angle, you automatically know which would be the greatest side. Similarly, smallest angle will have the smallest side. So if this particular angle is the smallest in this triangle, then this side would be the smallest. So smaller angle always has a smaller side opposite to it, and a greater angle will have a greater side opposite to it. Now let's talk about two more rules, sine rule and cosine rule. While sine and cosine are typically taught in trigonometry classes, but since these two rules are associated with triangles, so we are covering them here. Now if you look at this triangle, triangle ABC, we have denoted the length of the sides by small a, b and c. So small a, length of side BC is small a, and this is opposite to angle A. Similarly, opposite, the side which is opposite to angle B has got a length of small b, and the side which is opposite to angle C has got a length of small c. Right, now let's look at the rules. Sine rule is a upon sine a. So this a, small a upon sine a, is equal to b upon sine b is equal to c upon sine c. Now what is the cosine rule? Cosine rule says that cosine of angle A is equal to b square plus c square minus a square divided by twice of bc. So if you want to remember it, you can remember it in this manner, that cosine of this angle, cosine of A, would be equal to the summation of the squares of these two sides, which the sides which are making this particular angle. So this side and this side are making this particular angle. So you have to square them and add them. So b square plus c square, and subtract the square of the third side minus a square, and divided by, in denominator, it is twice of the length of these two sides. Again, these two sides are making this angle. So divided by 2bc. Similarly, for cos b is equal to c square plus a square minus b square divided by 2ca, and cos c would be equal to a square plus b square minus c square divided by 2ab. Now let's look at what is angle bisector, or what is angle bisector theorem. So first of all, let us understand what is angle bisector. So in a triangle, if a line segment is dividing an angle equally, so this angle A, it is divided by this line segment AD, then this AD is called angle bisector, because it is dividing this angle A equally. It is bisecting this angle, it is dividing it into two equal parts. So this particular angle is equal to this particular angle. In that case, AD is called angle bisector. Now the theorem says, in case of angle bisector, if AD is the angle bisector, then AB upon AC is equal to BD upon DC. So if a line bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the other two sides. So AB upon AC is equal to BD upon DC. So if you look it here, if you look carefully, so in numerator, on left hand side numerator is AB, on right hand side numerator is BD. So AB is this and BD is this. So they are on the same side of the angle bisector. So both are numerators, and denominators would be on the other side of the angle bisector. So here it is AC and here it is DC. They are on the other side of the angle bisector. So that is how you can remember it. It is AB by AC is equal to BD by DC. Now the converse of angle bisector theorem is also there. What happens in converse of angle bisector theorem? That if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle, which means that, let us say, this BAC is an angle and this AD is a line which is intersecting this, which is dividing this angle A. Now if this point D is equidistant from AB and AC, so if DB and DC are equal, then we can say that this AD is actually an angle bisector of angle A, right? So if we are able to determine that DB and DC are equal, then we can say that this AD is an angle bisector of angle A. Now let's talk about medians. What is a median? A median is a line segment which joins a vertex and the midpoint of the opposite side of a triangle. So here is the vertex and here is the midpoint of the opposite side. So the line which joins the vertex and the midpoint of the opposite side is called a median. There are three medians in a triangle. So one is AX, another one is BY, and another is CZ. And all three of them intersect in one common point, which is called centroid. So here G is the centroid. Now there is a two-third rule in medians. What is that two-third rule? Two-third rule says that AG is equal to two-third of this median, right? So if the median is drawn from vertex A, then AG is equal to two-third of this median AX. Similarly, BG is equal to two-third of this median BY. Similarly, CG is equal to two-third of this median CZ. Another rule says that three times of the summation of the squares of these three sides, so three times of AB square plus AC square plus BC square is equal to four times the summation of the squares of the medians. So four times of AX square plus BY square plus CZ square, right? Now let's talk about angle bisectors. So we have just seen angle bisectors earlier. So let's talk about them in slightly more detail. So in a triangle there are three angles, so there are three angle bisectors possible, and these three angle bisectors intersect each other at a common point. This common point is called in center. We have represented it with G. So this is called in center. Now this particular in center is equidistant from these three lines, and we can actually draw a circle using this G as a center, and the radius of that circle would be GD or GF or GE, because these three are equal. So if you use this G as a center and draw a circle, then that circle would be inscribed inside this triangle. It will touch each side at only one point. So it will touch AB at E, BC at F, and AC at D. So it is touching each side at one point each. This is called in circle. Now you have to remember that this BG is not extended to D. So this BG might hit the other side here or here also. So GD is a separate line. GD is actually a perpendicular to AC. Similarly, GE is perpendicular to AB, because here it is the radius. It is not the extension of BG. It is not the extension of the angle bisector. Extension of angle bisector might hit AC anywhere. It is not GD, right? So this is what you have to remember. Now next is altitude. What is an altitude? Altitude is nothing but when a line segment through a vertex and perpendicular to the side opposite the vertex. So this particular line is starting from A and it is hitting the other side at X, and it is perpendicular to this side, right? So if I drop a perpendicular from this vertex to this line, this is called altitude. So there are three altitudes: AX, BY, and CZ. and they intersect at the common point called orthocenter. Here O is the orthocenter. And one property here is that angle BOC and angle A, if you add them, BOC and A, then the summation is 180°. Similarly, AOC plus opposite angle, which is angle B, if you add them, the summation is 180°. Similarly, AOB, so this angle AOB, if you take this angle and add it to the opposite angle, which is angle C, then the summation is again 180°. Now, there are some interesting results, like in an acute triangle, the orthocenter always lies within the triangle, while in a right triangle, the orthocenter coincides with the vertex of the right angle. So this orthocenter coincides with the vertex of the right angle. So here, this is the right angle triangle, and right angle is made here. So this orthocenter is lying actually on this vertex. While in an obtuse triangle, the orthocenter lies outside the triangle because altitudes are meeting each other at somewhere outside the triangle. So this orthocenter also lies outside the triangle. Now there is one more theorem of right angle, which is called right angle altitude theorem. In a right angle triangle, if I drop an altitude from this vertex to the opposite side, so this vertex means the vertex where right angle is made, right? Importantly, this is the vertex on which right angle is made. So in a right angle triangle, this is the right angle, and from this vertex, if I am dropping an altitude to the other side, then the length of that altitude h square of it, h square, is equal to x into y. So this altitude is dividing this other side into two segments. One segment is this AD and the other segment is this DB, and their lengths are x and y. So h square is equal to x into y. Now, what are perpendicular bisectors? So perpendicular bisector is something that if I want to know the perpendicular bisector of BC, I will first find out where is the midpoint. So X is the midpoint of BC, and just drop a perpendicular on this midpoint. Now perpendicular bisectors might or might not pass through these vertices, right? So this OZ is not passing through B here. Similarly, OY is not passing through C, and OX is not passing through A. Right? So wherever these three perpendicular bisectors intersect with each other, that point is called circumcenter, and we have represented it with O. And circumcenter O is equidistant from A, B, C, and B. So this is equidistant from the three vertices. So then we can actually draw a circle here, which is called a circumcircle. So this circle is outside the triangle, but it is touching it at 3 points, A, B, and C. And the center is this circumcenter. So with this center, we have drawn this circle, and the radius of this triangle is OA or OB or OC, because these three are equal. So radius is OA, OB, or OC. Now again, some interesting results, like circumcenter of an acute triangle is always located inside the triangle. Circumcenter of a right triangle is at the midpoint of the hypotenuse. So circumcenter of, this is a right triangle. If I draw a circumcircle for this right triangle, then its center would be at the middle of the hypotenuse. This is a very important result, and this is also asked in many of the exams, right? So this center of hypotenuse acts as the circumcenter of a right triangle. In case of an obtuse triangle, the circumcenter lies outside the triangle, and it is opposite to the obtuse angle. So it is not only lies outside, it is also opposite to the obtuse angle. Now there is a relationship between centroid, orthocenter, and circumcenter. These are collinear, and they lie on a line called Euler line. So here we have represented circumcenter as C, centroid is G, and orthocenter is H. The relationship between them is Hg divided by Cg is equal to 2:1, right? Or you can say that HG is double the CG. This distance HG is double the distance of CG. Now let's move on to the next topic, which is congruency of the triangles. What are congruent triangles? When do we call that two triangles are congruent? When they are exactly same to each other. All their three sides are equal to each other, and their three angles are also equal to each other. Then these are called congruent triangles. They are same triangles. But how do you know that whether two triangles are congruent or not? So there are certain rules which you can use to find out whether the triangles are congruent or not. And first of them is SSS, side. If you are able to determine that the three sides of this triangle are equal to three sides of this triangle, then you can easily say that these are congruent triangles. Another method is SAS. So if you are able to determine that this side is equal to this side is equal to this side, and the angle between these two sides is equal to angle between these two sides, then also you can say that angles are congruent. So this rule is called SAS, side angle side, right? Remember that this angle should be between these two sides, which are equal to the sides in the other triangle. Then another rule is ASA. So if this angle is equal to this angle and this angle is equal to this angle, and the side in between these two angles are also equal, then also we say that these triangles are congruent. This is called ASA rule. Then there is an AAS rule, wherein two angles, this angle is equal to this angle is equal to this angle, and this side is equal to this side. So AAS, angle side. In that case also we say that these are congruent triangles. And last is RHS. So if two triangles are right angle triangles, then if we are able to determine that their hypotenuse are equal and one of the sides are also equal, then also we can say that these are congruent triangles. Now once we have been able to prove that two triangles are congruent, then what does it mean? Then we can easily say that all three sides of a particular triangle are equal to the corresponding sides of the other triangle. Similarly, the angles of a particular triangle are equal to the corresponding angles of the other triangle, right? So for example, if you are able to determine that through SAS these two triangles are congruent, then you can safely say that even this side is equal to this side, and even this angle is equal to this angle, and this angle is equal to this angle, right? Because these are congruent. Now let's look at what are similar triangles. So similar triangles, they have same shape, but they are not necessarily the same size. Their corresponding angles are equal, but their corresponding sides are not equal. They are in the same ratio. So what is the meaning of corresponding? So corresponding angles means, so let us say this is angle X and this is angle X, they are equal. So here angle A, the measure of angle A is X and measure of angle P is X. So these are equal angles. So these are called corresponding angles. So angle A and angle P are called corresponding angles. Similarly here measure of C is Z and measure of R is Z. So C and R are corresponding angles. And measure of Q is Y and measure of B is Y. So B and Q are corresponding angles, right? Similarly, corresponding sides means, so this angle is Y, the measure of this angle is Y, opposite to is side B. Similarly, measure of this angle is Y and opposite to is side Q. So B and Q are corresponding sides. If you look at this, that measure of this angle is X, corresponding side is, opposite side is A. So here we will find where is X. So this is the measure of the angle is X here. So opposite side is P. So here A and P, they are corresponding sides. So sides opposite to the equal angles are corresponding sides. So this is very important that you should know what are corresponding sides, because similar triangles or congruent triangles, they are all about corresponding sides and corresponding angles. If you don't understand it well, then you will not be able to figure out whether which triangles are congruent or which triangles are similar. Now here we have determined which are the corresponding sides, so they will be in the same ratio. So A divided by P, would be equal to B divided by Q would be equal to C divided by R. Now, there are some tests also to determine whether the triangles are similar or not. So first test is AA. So if you are able to determine that two angles are equal, two angles of a triangle are equal to the two angles of another triangle. So here if you are able to determine that this angle is X and this angle is Y, and here also there is an X and Y, then you can easily say these are similar triangles. So two angles of a triangle should be equal to two angles of other triangle, then these are similar triangles. Then there is SSS. If three corresponding sides are in the same ratio, then also we can say they are similar triangles. SAS, if the ratio of two pairs of corresponding sides are equal and their included angle are also equal, then also we say that these are similar triangles. So which means that ratio of two pairs, so let us say A divided by P is equal to C divided by R. This we are able to determine, and the included angle is also equal, Y. Then we can say that these two are similar triangles. There is another property of similar triangle is that ratio of the sides of the similar triangle is equal to the ratio of altitudes is equal to ratio of medians, ratio of angle bisectors, ratio of in radii, and ratio of circumradii, right? And ratio of areas is also equal to ratio of squares of corresponding sides. So if I want to calculate the ratio of the areas of these two triangles, so area of triangle ABC divided by area of angle PQR, then it is equal to A square by P square is equal to B square by Q square, or this is equal to C square by R square. So if I am able to find only this A and P, then I can find the ratio of these two areas. Now let's look at how to calculate the area of the triangle. Area of the triangle is half base into height, right? So here uh, we have dropped an altitude from this vertex to this side. So this is the height of the triangle and this is the base. So the line on which the side on which altitude is dropped is called base, and you can drop altitude from any vertex to the opposite side, right? So this is half base into height. In this right angle triangle, it is clearly this is the height because this is also an altitude, so this is called height, and this is the base, so half h into b or half b into h. Area of an equilateral triangle, so in an equilateral triangle all three sides are equal. Let us say one of their side is a, so all three sides would be a, so their area would be root 3 by 4 a square. And now if you are not able to calculate the height of the altitude, then how do you calculate the area? So suppose you know the length of all three sides, so a b and c, these are the length of the sides, but you don't know what is the height of any of the altitudes. Then how do you calculate the area? So the formula is the square root of s into s minus a into s minus b into s minus c, where s is the semi parameter. Semi parameter means half of the summation of these three sides. So perimeter is a plus b plus c, and semi parameter is a plus b plus c by 2. So this formula is rarely used, but it is good to know this formula. Now there is another theorem called Apollonius theorem. What does Apollonius theorem say? That in a triangle, the sum of the squares of any two sides equal to twice the sum of the square of the median to the third side and square of half the side, right? So AB square plus AC square, so sum of the squares of any two sides is equal to twice the sum of this median, which is dropped on the third side, so twice of AD square plus BD square. So this median is dividing the other side into two halves, so you pick up any one half and square it, so this becomes BD square. So twice of AD square plus BD square. Instead of BD, you can also say CD square. So twice of AD square plus CD square, because BD and CD are same. So AB square plus AC square is equal to twice of this median's square plus this segment's square, BD square, right? This median is dropped on the third side. Third side means these two sides we are using in Apollonius theorem, AB square plus AC square. So AB square plus AC square is equal to twice of this AD square plus BD square. Now let's look at Thales intercept theorem. What does Thales intercept theorem say? That in a triangle ABC, if DE is parallel to BC, if we have drawn a line DE which is parallel to this line BC, then AE upon AC is equal to AD upon AB is equal to DE upon BC. So this is basically a derivative of similar triangle. So this is an application of similar triangles. So what do I mean by similar triangles is that actually angle ADE and angle ABC, they are similar triangles. Why? Because they have the same angles. So ADE, one of the angle is A. In ABC also, one of the angle is A. In ADE, this angle D is equal to angle B in the bigger triangle, and in the smaller triangle, angle E would be equal to angle C in bigger triangle. Why they are equal? Because they are corresponding angles. So we saw at the start of this video that corresponding angles are equal, and they are formed when two parallel lines are intersected by a transversal. So that is why ADE and ABC are similar triangles, and in the similar triangles, corresponding ratio of corresponding sides is equal. So that is why AD divided by AB is equal to AE divided by AC is equal to DE divided by BC. So smaller triangle side divided by bigger triangles corresponding side is equal to smaller triangle side divided by bigger triangles side is equal to smaller triangle side divided by bigger triangles corresponding side. Now there is another theorem called midpoint theorem. So what does midpoint theorem say? That if we join the midpoints of these two sides of AC and BC, if D is the midpoint of AC and E is the midpoint of BC, and if we join them, then this DE would always be parallel to the third side. So DE is parallel to AB. This is called midpoint theorem. Now there are some other useful results, like in a triangle, if the bisectors of angle B and C, they intersect at O, then angle BOC is equal to half of this opposite angle plus 90 degree. So A by 2 plus 90 degree. Another important result is that, or useful result is that, in a right angle triangle, this is a right angle triangle ABC, and if we drop a median to the hypotenuse from this vertex, so BN is the median, then this BN is equal to AN is equal to NC. So median to the hypotenuse is actually half of the hypotenuse. So this AN and CN, they are the half of hypotenuse. So this hypotenuse is divided here at N, equally divided at N. So this median is equal to half of hypotenuse. Then another important result is that in a right angle triangle, the triangles on each side of the altitude drawn on hypotenuse are similar to the original triangle and to each other too. So which means, so this is an altitude drawn on the hypotenuse. So now this triangle and this whole triangle, they all are similar to each other, right? So triangle BCA is a bigger triangle, the original triangle. This is similar to triangle BDC. BDC is similar to triangle CDA. The order of these vertices written in these triangles is very important here. So BCA is similar to BDC. Why we have written BDC? Because in BCA and BDC, this angle is common. So this is equal. In BCA, C is the 90 degree angle. In BDC, D is the 90 degree angle. So both of them will be at the same place. So here it is in the middle. So C is in the middle. So here also D would also be in the middle. So they have to occupy the same place in the naming. So B also occupied first place, same place in both the triangles names, and the C and D also occupied the same place. And A and C would also be equal. That is why they are at the end. And if you compare it with CDA also, so CDA, right? So here D is 90 degrees, so it is again it is coming in between, like in other triangles. This angle A is common between BCA and CDA, so it is coming at the end. So here also A is coming in, here also A would be coming at the end. So that is how you have to order the names also. Now let's look at Pythagorean triplets. What are Pythagorean triplets? A Pythagorean triplet consists of three positive numbers a, b and c such that a square plus b square is equal to c square. Now some of the common Pythagorean triplets are these 3 4 5, very common, 5 12 13, which means 13 square is equal to 5 square plus 12 square. 8 5 17 is also a Pythagorean triplet, means 17 square is equal to 8 square plus 15 square. Or if we look at this 9 40 41, 41 square is equal to 9 square plus 40 square. So these are some of the common Pythagorean triplets. If you can remember all of them or at least few of them, it will help you in solving the questions quickly. That is the only purpose of showing Pythagorean triplets here, because if you can remember them, it will help you in identifying the triplets in the question and you can solve them easily. You can easily find out that this is a right angle triangle, because Pythagorean triplets are the sides of a right angle triangle. So if you are seeing that the three sides of a triangle are 9 40 and 41, then you can immediately say that this is a right angle triangle. Or if the sides are 12 35 and 37, then immediately this is a right angle triangle with 37 as hypotenuse, biggest side is the hypotenuse. Okay, so this is all for lines and triangles. So if you like this video, please press subscribe button given below this video and share it with others so that they can also learn. And as I said earlier, that if you have any doubts or any queries on the topics covered in this video, then please mention it in the comment section. I will revert to you in the comment section or maybe through a separate video. Thank you and happy learning.